Hello, today I will present cross-domain fusion learning with task-specific adapters published on CBPR 2022. This paper addresses the cross-domain fusion classification task, which is a challenging task that aims to classify images of unseen categories and domains with a few labeled images. The classifier is trained on the large dataset to generalize representations over domains, then adapt to the target domain using a support set. This figure shows how prior works and this paper approach to this challenging task. In common, there are task-agnostic weights for generalized representation over multiple domains and task-specific weights for adapting to the target domain. In prior works, an auxiliary network is trained to estimate task-specific parameters, which causes noisy adaptation and wrong predictions. In this paper, task-specific weights are trained directly on a support set without auxiliary networks. There are two approaches for task-agnostic representation learning. In SDL, a task-agnostic network is trained on ImageNet and further adapts to other domains later. In MDL, the objective is training a single feature extractor over multiple classification tasks. The network is expected to generalize a representation over domains. This paper proposes MDL with knowledge distillation. Feature extractors are trained in SDL for each domain and distill their knowledge into a single task-agnostic network. This is a figure of task-specific adapters. They are attached after each convolution layer, and the feature is transformed by a pre-classifier and fed to a non-parametric classifier. There are two connection types. Serial adapter is sequentially applied after the layer, and residual adapter estimates residuals that are added to the layer output. There are two parameterizations. First is to do convolution with matrix form parameters, and the second is to do element-wise multiplication with vector form parameters. Finally, the paper proposed a pre-classifier to adapt features to the target task. The transformed feature is fed to non-parametric classifiers such as NCC, MD, LR, and SVM. In the experiment, the paper used a metadata set consists of 13 diverse datasets, which is the standard benchmark for few-shot classification. The paper used ResNet as a backbone and attached task-specific adapters in each block. This is a classification accuracy with MDL proposed in this paper. TSA overperformed prior works for seen domains, and especially for unseen domains. This is a result for SDL. TSA outperforms other methods on almost all domains. CTX seems competitive, but it's much more complex to compute than TSA. This is a result for various task-specific options. Among classifiers, NCC is the best for seen domains and SVM is the best for unseen domains. And the result shows that training weights directly is better than estimating its parameters using an auxiliary network. Among two connection types, residual connection is better than serial, especially in unseen domains. It's because the residual connection doesn't affect the pre-trained connections, so the network becomes robust. Matrix form parameterization worked better, and the pre-classifier improved the performance. As a result, the best options are training directly with matrix form residual adapters with a pre-classifier. There are some ablation studies. First, they found that 20 iterations are enough to get a stable solution. Next, they tested the effect by attaching the adapters only to some blocks and found that more adapters improved performance for unseen domains while maintaining performance for seen domains. Finally, they decompose a matrix form adapter as product of two matrices and see its effect. As a result, we can reduce the number of parameters without a performance drop. This paper achieves SORA on a cross-domain fusion learning task and can be applied to various feature extractors with negligible increase of number of parameters. However, it used existing old backbone and they fixed connection types and parameterizations for all layers, which can be suboptimal. So future works can propose flexible adapter structures and tune them on the target task. These are the references and thank you for your attention.